Okay, so I can't stress to you enough how important this lesson is. There are some lessons that are just kind of, they just kind of go with the lesson before it, just to kind of like I don't know what the word is, a continuation, all right, of what we did before. This kind of is that too, but this is really, really important. One should always take notes, okay? So, but this is one of those standout lessons, okay? You did a little bit of this in Algebra 1, but from what I hear from you guys, you didn't do a lot of this, or it didn't really sink in. So I'm going to try to do my best to get you to understand how to do these things. Okay, factoring. When I think of factoring, this is not like a good book definition of this, but it's kind of like backwards multiplication. And you're thinking division. Well, there is some division that's involved in it, okay? But it's kind of like doing the opposite of what we just did in that lesson 5.1, all right? So, for instance, that lesson 5.1, I'm just making something up. What if we had like 5x times 3x squared minus 2x plus 1, all right? What if we had something like this? All right, this is what we did yesterday, correct? Okay, it's an easy version of it. But what would we get? We would get what? 15 x cubed minus 10 x squared plus 5x. All right? So that's what we did in section 5.1. But in this section, we're going the other way. I think I talked about this in the last section, okay, but I'm going to say it again. Is everybody paying attention? Doesn't seem like everybody is. I didn't say you, did I? Don't be guilty if you're not guilty. All right, let's take a look. So what we're going to do today is this. We're going to take this thing right here, and I'm going to ask you to factor it. Okay? So you're taking this and you're turning it in to what we started with earlier. All right? That's why I say it's kind of like backwards multiplication. You see that? Okay, I'm kind of flipping the question and the answer. So what I have to do is this. Find a thing called the greatest common factor. You remember that, don't you? You learned that when you're a little kid, they talked about greatest common factor. Well, what is the greatest common factor? Well, it's the largest number that divides evenly into all three of these terms. All right, so let's just take a look at the regular numbers first. I got a 15, a 10, and a 5. What number divides evenly into all three of those numbers? A 5 does, so we put a 5 out here. You with me on that? And then you look at the variables. I got an x cubed, an x squared, and an x, or x to the first. Which one of those divides evenly into all three of them? How many x's are in all three of them? Are there 3 x's in all three of them? There's only 1 x in all three of them, correct? One common x, the greatest common factor, right? You say, well, Mr. Hamrick, there's 3 x's here, but are there 3 here? No. Are there 3 here? No. Okay, what about the x squared? Is there an x squared inside of this? Is there 2 x's? Yeah. Is there an x squared there? But not here. All right. Let's do the smallest one. Is there an x in all of them? Yes. Everything you can divide by an x. You with me? So that's our greatest common factor. So it's going to be a 5 and an x. Now, how did I get the 3x squared from this? That's it. Remember I said earlier, okay, it's kind of like, I said, it's not technically division, but you're going to do some division in it. All right, this is where we do the division. So you pull out the greatest common factor, and how do you know what's left over? You take this and you divide it by the greatest common factor. How do I know that I can divide it? Well, because when I pulled out the greatest common factor, I purposely pulled something out that I could divide it by, right? Everything in here can be divided by that 5x. So I know I can divide everything by the 5x, or I wouldn't have made this 5x. Make sense? So what do? Take this and divide it by 5x. 15 divided by 5 is 3. X cubed divided by x is x squared. Okay, and then put a minus. Okay, put a minus right there, minus right there. So now you take this 10x squared, and you divide it by your greatest common factor. 10 divided by 5 is 2. X squared divided by x is x. And then you took this, divided it by this. 5 divided by 5 is 1. X divided by x is 1 times 1 is 1, and there you go. So what we did is we took the question, or we took the answer, and we turned it into the question that we originally started with. Everybody up here? Not everybody is. I don't get it. You guys are complaining about you didn't know how to factor in Algebra 1. I'm showing you how to do it, and I got 3 or 4 of you having little conversations like it's a CP class. This is not CP. This is honors. You should be paying attention. All right. So that was factoring by the greatest common factor. All right. So I'm going to show you, I don't know, 4 maybe different ways to factor. All right. That's the first one. That's always the first one to look at. Always, always, always. When it says to factor, see if there's a greatest common factor. Sometimes there is, sometimes there's not. You're like, well, how can I factor if there's not something in common? Well, we're going to show you. All right. But the first way that you should always look is to see if there's a greatest common factor. So now that was just made up. I just did that in my head. But let's do an actual example. So example 1. And all these say to factor. Again, what is a factor? We talked about this the other day. Remember, 3 times 2 is 6, correct? 6 is the what? It's the product. What is the 2 and the 3? Or the 3 and the 2? Right, those two things right there are factors. So when it says to factor something, we're trying to find what numbers are being multiplied together to get that thing that you started with, like right here. So it says to factor, and I want to factor 15x squared plus 45x. Okay? So that's what we're trying to factor. I want to find out what times what equals this thing right here. All right? So first thing you do is find the what? Greatest common factor. That's right. So I got a 15 and a 45. What's the largest number that divides evenly into 15 and 45? 15. That's right. So there's a 15. So I pull that out in front. What about the x's? I got an x squared here and an x here. Which one do I pick? Do I pick the biggest one, x squared? No, because it's got to divide evenly into both of them. Only an x divides evenly into both of them. So I pull out an x. Everybody with me? So that's my greatest common factor. Now what I got to do is figure out what is being multiplied by this in order to get this. So I put a parentheses, and how do I do that? I take this first term and do what to it? I'm pulling it out, so I'm dividing it out, correct? So I'm going to take this and divide it by this. So 15 divided by 15, 1, x squared divided by x is x. Plus, what about this? 45x divided by 15. 45 divided by 15 is 3. X divided by x is 1. 1 times 3 is 3. There it is. You just factored it. You could always double check. How can you double check to see if you got that right? Well, you could distribute. Okay, you could distribute. You could multiply those two things together. Okay, if I multiply those two things together, I should end up with the question. All right? You don't have to do that if you're stressed for time or something like that, right, on a quiz or a test. But if you have the time, instead of turning it in early and sitting around and twiddling your thumbs, all right, or putting your head on the desk, you could always go back and check to see if you got it right. Now, of course, you'd have to check correctly, right? If you made a mistake with your checking, that could be a problem. But if you check correctly, you should be good. Let's do another one. That was A. This one's B. This one's a little weirder looking, but it still works the same way. Thank you. It sure is. Is it minus? Because I wrote it the way I wrote it with you guys, but I need to change that on my notes. Let's do this in black. Give me a second. I got to change it in my notes because next year I won't remember, so I'm going to do it now. So that's a minus. And that's a minus. All right, there we go. Okay, so now let's take a look at this. How many terms do I have here? 2. A lot? No, I don't. I got 2. I got this one, and I got this one. Everybody with me? So what's in common with both of those? A 3x minus 7, right? That whole parentheses right there is in both of those terms, correct? So that's my common factor. That's the only thing I have in common with both of those. So guess what I'm going to do? I'm going to pull that out. Okay? Because everything's being multiplied by 3x minus 7, isn't it? This is being multiplied by 3x minus 7. This is being multiplied by 3x minus 7. So I pull that greatest common factor out. What do I find? I got to put a parentheses here. Let's find out what's left over now. Let the announcement go on.
Would the following seniors please come to the office? Trent, Kevin, Gael, Rose, India, and Leona. Thank you.
All right, so now what I'm going to do is what we did before. Okay, we've done this twice already. So I take this and divide it by my greatest common factor. So if I take this and divide it by 3x minus 7, what am I left with? Just the 2x. Put your sign, plus. Now I'm going to take this and divide it by 3x minus 7. What do I get? A 5, and then there you go. Now it's factored. Now, if remember I said checking it? If I went through and checked it, I would get something different than this. All right, what I would have to do is multiply this through, multiply that through, add my like terms, and then when I multiply this together, I would get the same thing. All right, so it's a little different. They're leading you up to something. On this thing right here, okay, this example right there, they're definitely leading you up to something you're going to see in a little bit. All right, that's why they put that in there. I know exactly what they were doing. Okay? Now, that was the kind of easy stuff. That was elementary. Now we're really going to get into the stuff that you're going to be using over and over and over again. All right, so let's get it now. Let's get used to it, and it should be good. This is called, what was the name of that lesson, by the way? It had some big word in there. I didn't even talk about it. Okay, quadratic. What in the world is a quadratic? It could be a formula. Okay. A formula, though, it's something equals something. We're not doing that quite yet. Okay, we will pretty soon, very soon. Okay, but a quadratic fits this form. It's got squared in it, but it's not just something squared. So it's ax squared plus bx plus c. This is considered to be a what? A quadratic. It's not an equation. Why is it not an equation? There's no equal sign. That's right. Okay, so, but we will, very, very soon, we will do a quadratic equation. All right? But right now, this is just a quadratic polynomial or trinomial, right? It's 3 terms. We just call it a quadratic polynomial. It's not an equation, but we will very soon get to an equation. So that means if you have some number times x squared plus some number times x plus a constant, that's considered to be a quadratic. So what we're going to do is we are going to factor quadratics. This is the most common, easiest, I guess. I don't know if it's the easiest. Nah, I'm not going to say it's the easiest, but it's a very, very common quadratic to solve. So I'll tell you what, let's do this before we get to this. I didn't put this in my notes, but now I'm thinking about it, I should do this. My answer, when I factor this thing, is going to look like that. All right? Everybody with me on that? It's going to look like something like that. So for instance, let's do one. Let's start with this. Go backwards like I did with that greatest common factor. That kind of made sense, didn't it? Started off with the question, right? The multiplication, and then we just switched the answer in the question. All right, that's what we're going to do. So let me just do a super easy one. Let's go x plus 2 times, let's go x plus 3. Make it as easy as I can. This is not really factoring. I'm getting you to the factoring part, okay? So let's just deal with this. You know how to do this. It's 2 binomials. Use the FOIL method. What do you get? You get x squared plus what? 3x. Can we do a little bit of this in our head? 3x plus 2x, what's that going to be? Plus 5x, correct? Plus what? Plus 6, okay? So there we go. So that's my answer. Do you remember what we're going to do? We did this with the greatest common factor. We're going to do the same thing with this. We are going to take the answer and put it here. So how in the world did we get from this to that? Well, let's see if you can see what's going on here. Look at the 2 and the 3. I got a 6 out of it, and I got a what? A 5 out of it. Tell me something about 2 and 3 to get a 6 and to get a 5. So how'd you get the 6 first of all? 2 times 3. You multiplied, didn't you? Okay? So to get the 6, you went 2 times 3. What about the 5? You added them. You added those same 2 numbers, correct? So what I have to do is this. Now, we already know the answer to it, all right? But let's pretend we didn't. What if I asked you to factor this? Well, it's a trinomial. It's in this form. It's in this quadratic form, isn't it? What's the a, by the way? Just be a 1, okay? They're a little easier when the a is a 1. So there's my ax squared plus my bx, the b is 5, plus my c, which and the c is 6. Everybody got that? All right, so what we need to do, let's just start from scratch instead of putting the x's there. What we're going to do is this. I'm going to look at this and I'm like, oh, okay, this is one of my quadratics. I wonder if I can do it this way. Not every single quadratic trinomial works this way, but there's a lot that do. All right, so this is one of the options that you have. All right, it's not always, sometimes it's really difficult. This is pretty easy one though. So remember, I'm going to do the FOIL method, right? It's kind of like the backwards FOIL method. A lot of teachers will say that. I say it myself, okay? It's kind of like the backwards FOIL method. So what I want to do is what times what equals x squared? Just x and an x, correct? Now, watch this. Now, everything's plus, so there's no way I'm going to have negatives in there, correct? Okay, because they multiply to be this and they add up to be this. Everything's plus. So now what I got to do is figure out what times what equals 6, and those same 2 numbers add up to be what? 5. So I got to think of it. Am I going to use 6 and 1? 6 times 1 is 6, right? But what if I put a 6 here and a 1 here? I would get this one, but when I add them up, what would I get? I'd get a 7, wouldn't I? All right, and that's not a 7, so I can't use 6 and 1. Could I use 1 and 6? It's going to be the same thing, isn't it? Okay, if I put 1 and 6. Sometimes, especially when you have 1 plus, 1 minus, changing the order will make it work, all right? So what you have to do, this is where thinking comes in. You have to think of 2 numbers that multiply to be 6, and those same 2 numbers have to add up to be a 5, all right? And again, I picked one that's super easy for you, all right, that you can just do in your head pretty quick. So what do we get? 3 and what? 2. Or I could have gone 2 and 3. Would it make any difference if I put a 2 here and a 3 here? No, because these 2 have to multiply to be what? 6, and they have to add up to be 5. Make sense? All right, that's the key to this kind of factoring. So now let's actually do an example from the book. When they start putting negatives in there, it just adds to the difficulty of it. But once you get used to these, as long as they're relatively easy numbers, you can figure it out. So it says to factor. That's what this problem says to do. So I recognize that it's a quadratic trinomial. All right, so I'm going to put the 2 sets of parentheses. I know it's the backwards FOIL method. So let's do the first part. First part's kind of easy. This times this is x squared. What am I going to put first? X and x. Now, let's think about this. This number here and this one here have to multiply to be what? Negative 21. Not just 21, but negative 21. And those same 2 numbers have to add up to be what? Negative 4. Now, that's a key. So 2 numbers that multiply to be negative. Tell me something about the signs of those 2 numbers. One's got to be positive and one's got to be negative. That's the first thing that I like to do. All right? And now you got some options. Not too many options. What times what is 21? There's only a couple things. 7 times 3, you could pick 21 and 1, but is there any way you can get 21 and 1 to add up to be a negative 4? No. But 7 and 3, yeah, definitely. 7 and 3, if I subtract them, right, I can get a 4. So which one's going to be 7, which one's going to be 3? When you add them up, your answer has to be negative. So if I'm going to use 7 and 3, which one's negative, which one's positive? It's going to be x plus 7. It's right. I'm going to do the 7 first, okay? Because when I add them up, 7 and 3, 7's the bigger number, right? And so when I add them up and I get a negative answer, 7's got to be negative. And then this has to be positive. So let's just double check. Do these multiply to be negative 21? Yes. Do they add up to be negative 4? Yes, they do. So that is factored. If you wanted to, you could do the FOIL method on it and make sure. Okay, x times x is x squared. That gives you negative 7x. That gives you positive 3x. That's negative 4x. And that gives you minus 21. So it works. So you got to do a little bit of arithmetic in your head. That's why it's nice to know your multiplication tables. People say all the time, well, why do I have to know my multiplication tables? Because I got a calculator. If you know your multiplication tables, you could just do that in just a second, all right? Seconds. Calculator, pull your calculator. Oh, what times what? This times this. Da, 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 da. It's too much, all right? There's times where you just want to do things quickly in your head, and this is one of those times. Yeah. No. Let's do another one. Part B. How do you not know your multiplication tables? You're in Honors Algebra 2? Right, you should all know up to your 12s. One day, not today, I'll tell you a story about how I learned my multiplication tables. It was not nice. No, the enforcer, I was the kid. My dad did not have my dad had his belt. That was the enforcer, but he didn't write on it. And he didn't whip me. I'll tell you real quick. So I was in Australia. When I left America, I was in second grade. Right, I was 8 years old. I was in second grade, about like halfway through second grade. We went to Australia, and the kids my age were in third grade. Well, they had already learned their multiplication tables, and we hadn't learned them in second grade yet. So I didn't know my multiplication tables. I go into school, all the kids in my class knew their multiplication tables, so I was behind. My dad found out about that. My dad's a teacher. That's the whole reason why we went to Australia. And my dad found out about it, and he's like, well, you got to learn your multiplication tables. So he'd send me into a room. He's like, okay, learn them, right? And wasn't just one day. It was a series of days. And I'd come out and he'd quiz me on it. Okay, 3 times 5, 15. Okay, good. Whatever. He'd give me easy ones. But then he'd give me ones like, I don't know, 8 times 7 or something like that, right? And I forget exactly what it was. And I'd say 8 times 7, 8, 7, 6, 8. Yeah, too slow. Get back in there and learn it. And so I got to go back in there. I mean, this was over and over again. I was almost in tears by this point. It's a miracle that I'm a math teacher today but it worked. He made me learn them, and I learned them, and I got caught up with the rest of my class. So that's what I remember about learning my multiplication tables. It was not a pretty sight, but I learned them. All right, let's do this one right here. So it's a trinomial. So I put the 2 sets of parentheses, okay? This times this, what do I do first? Put the x in the x. Now watch, these multiplied together is positive, but when I add them together, I get a what? I get a negative. So what are my signs going to be? Negative and negative. That's what I like to do first. Before I actually think about the numbers, I like to think about what signs I'm going to put in here. Does that make sense to you? If this is positive, these two could be both positive, right? Or they both could be negative. Why do you think they're not positive right off the bat? Because when I add them up, I have to get a negative, all right? So there's no way they're both positive, so they have to both be negative. Now, I got several options with 24. I got 24 times 1. I got what? I got, 2 and 12. I got 6 and 4. I got 8 and 3, okay? So you have to know those multiplication tables, okay, very quickly. So what numbers would add up to be a negative 11 out of those options? The 8 and the 3. Does it matter which one is the 8 and which one is the 3? No, because they're both the same sign, it doesn't make any difference. So you can go like this. If you wrote the answer x minus 3 times x minus 8, is that the same thing? Absolutely. Same exact answer. Either way, I would accept. I don't have any preference whatsoever. Let's do another one. All right. Now, this one might look a little scarier. Does this look like our trinomial quadratic, or quadratic trinomial, whatever you want to call it? No, because I got the cubed, then I got an x, and then I got an x. So I can't do it that way. I can't just put my two sets of parentheses. So what do you think I'm going to look for? Look for the what? Greatest common factor. Okay, always look for that first. Okay, I really should have probably mentioned it here. Was there a greatest common factor with these three? No, there's nothing in common with all three of those. So I move on to another way of factoring. So this one right here, there is a greatest common factor. So what is in common with all three of these? A 3 is in common, that's right. Okay, and what about the x's? Just an x, right. But I don't want this one to be a negative. If I just pulled out a 3, then I'm going to be negative x cubed, right? So most of the time, I would want to pull out the what? The negative as well, all right? Everybody with me on that? It makes it a lot cleaner in the end, okay? It just makes it a lot easier for you. What about the x's? I'm going to pull out a what? An x. And now let's see what's left over. So I'm going to take this divided by negative 3x. What do I have left? Just an x squared. Do you see why it was nice to pull that negative out because of this? Now you got to be careful here. This is 15 divided by negative 3, which is what? Negative 5. So you got to make sure you put the negative there. All right? Because again, if you wanted to check this, you would do the distributive property. Negative times negative is what? Positive. All right? And then what? X squared divided by x is x. Then do this. Take this negative 36 and divide it by negative 3. Negative divided by negative is positive. 36 divided by 3 is 12. X divided by x is 1. There we go. Now, what we need to think of, we need to think what times what, and keep this negative 3x on the outside. What's the first part going to be? X and x, correct? These multiply to be positive, but they add up to be negative. So what are my signs going to be? They're both positive? Okay, both negative. I thought I heard positive. Okay, they're both negative. Now, what gives you 12? What multiplies to give you 12? 12 times 1, 6 times 2, 3 times 4. Are any of those, if I add them up, going to give you a negative 5? 12 and 1. Is there any way you can get a negative 5 out of those? No. What about 3 and 4? There's no way I can get a negative 5 out of that. What about 6 and 2? That's a little closer, but still, I can't get a negative 5 out of this. So, guess what? This is as far as I can go. All right? Because even though that looks like a trinomial quadratic or quadratic trinomial, it doesn't factor. There's nothing, well, no integer numbers anyway, that multiply to become this. All right, so you would just leave it like that. Sometimes there are. All right, that's why they gave this problem to you, because sometimes you factor out a greatest common factor and then you're left with a quadratic and you're like, okay, let's factor the quadratic. Okay, if you could factor the quadratic, you need to. You can't just leave it like this. Got it? But in this case, can you factor this? No, there's no numbers that work. So you can't do anything with that. You would just leave it like that. Make sense? All right, let's do one where you can factor it, but this is a little trickier. Up to this point, what has the A been for all these quadratics? It's been a 1. Okay, it's not always going to be a 1. This is where it gets pretty tricky. All right, so, but we got a little method, a little way to do this that might make it a little easier for you. So this is example 3 in the book, and it says to factor should be writing this down. If you're not writing this down and doing these and thinking about them, you're in big trouble. First of all, it kind of looks like a quadratic, but it's not really in the form that we want, is it? What do we like first? The x squared first. Okay, so let's rearrange this a little bit, and we're really not doing anything to it. All we're doing is just rearranging it. So what's going to go first? 12x squared. What's going to go next? Right, it's a positive, so we put plus 5x, and then we put what? Minus 2. So this right here is really what we're going to factor. First thing I always look at to see is if there's anything in common. Is there a greatest common factor? I got 12, 5, and 2. Now, 2 doesn't go into 5, goes into 12, but there's no number that divides evenly into all three of those, is there? All right, so I can't do that. So what I'm going to have to do, I could do this. I'm not going to, but you could do this. This is the way that I was taught. For years and years, I don't know how many years I did this in high school and in college. I always did it this way. It's kind of like a guess and check. It takes too long. I'm not even going to show it to you. I'll start it off though. But like this times this needs to equal what? The first two. 12x squared, right? So you got a bunch of choices though. You got 12x times x. What else do you have? You got 6x and 2x. You got, right, 3x and 4x. And since you have a minus, you could put them the other way. All right? You follow me on this? That would be, and then you keep on trying and see what works. That is a real pain. Okay? I would not do it that way. Here's a method that I'd learn. A shout out to Mr. Jackson, because the kids are saying, because when I first came here, I think even when I taught, I don't even think I did it this way I'm going to show you. But this is the best way to do it. So here's what we're going to do. So the kids were doing it a certain way. I'm like, I've never even seen that way. People didn't even teach this to me. Even in college, they didn't teach this to me. So now, here you go. You're learning something that I didn't learn until I was actually teaching here at Red Lion. I taught like 17 years before I learned this. Isn't that crazy? I don't know where people were. Why didn't they tell me? So now I'm telling you. So what we're going to do is we're going to take the first one and the last one. We're going to multiply those together. So I'm going to take the 12 times the negative 2. What does that equal? Negative 24. Now, what I'm going to do is I'm going to take this negative 24, and I want to see what times what is negative 24, and those same two numbers add up to be positive 5. Okay, so here's what I do. I say what times what equals negative 24, and those same two numbers added up equals what? That middle one right there, 5. See what I just did? I took the last two, multiplied them together, I got this number negative 24. So that's the number that I'm going to use, negative 24. I'm going to say what times what is negative 24, and the same two numbers added together need to equal 5. Can you think in your head? Well, what do you got? You got 24 times 1. Is there any way you're going to get a 5 out of that? No. 12 times 2? No. What's another one? 6 and 4, I can't get a 5 out of that, can I? What else I got? 8 and 3. Oh, I can get a 5 out of that, can't I? If I subtract them, right? So what am I going to do? 8 and what? Negative 3. Because when I add them together, look, when I add them together, I'm going to get a positive 5. You with me? Okay? Now, I got to do something over here, though, to this. Actually, I'm not even going to put my parentheses here just yet. What I'm going to do is I'm going to rewrite that 5 as 8 plus negative 3. Did you hear me? That was really important, what I just said right there. I'm going to rewrite that middle one, that 5. I'm not going to keep it 5, but I am going to write it as 8x plus negative 3x. So this first one just stays the same, 12x squared. Plus, how do I rewrite 5? 8x. I'll tell you what, let's put plus negative 3x. Is that all right? I think that might be a little bit easier. Would you agree that so far that's the same exact thing? Yeah. And then what? It's at the end, minus 2. Okay? Now, we're going to do a thing. I forget the name of it off the top of my head, but I don't have time to worry about it. Watch this. By grouping. It's factoring by grouping. So we're going to take this, and we're going to take this, and we're going to factor both of these individually. So let's do this. The bell's going to ring in a second, okay? So, but just hang, let's finish this, okay? So when the bell rings, just hang on a second. So let's do this by greatest common factor, just as parentheses. What do we get? What's the largest number? 4x. Okay, and what do we get? 3x plus what? Just 2. What about this? Now, what I'm going to do, see that negative right there? I'm going to factor out that negative. So we just have 3x plus 2. See that? Now, do you remember what we did earlier? We had a problem earlier where we're going to use greatest common factor. Look, I got this and I got this. Is there a greatest common factor with both of those? Yes, there is. It's a 3x plus 2. Okay? And then what's left over? If I take this and divide it by 3x plus 2, what am I left with? A 4x. What happens when if I divide this by a 3x plus 2? What am I left with? A minus 1. And that is now factored. So this thing right here equals this. I could have sat there all day and tried a bunch of different numbers and just to see if they would work. Okay? Sometimes you get lucky and you get it right away. Sometimes you don't. This is a surefire method to do it every single time. All right? Write that down. Practice it. It's probably one of the most important things that we're going to do today. I didn't quite finish, and I really thought I'd get this done today, but I'm going to give you the homework, but I'm not going to collect it tomorrow. Everybody listening? Shh. Listen, I'm not going to collect it tomorrow because there's a lot on there you won't be able to do. I want you to try to do as many as you possibly can, and it's 1 to 37, but it's just the odds again. Now, I don't know which one's on here. I don't have it right in front of me. I don't know exactly which ones you can do, but do as many of those as you possibly can. My guess is maybe around halfway you might be able to do, okay? Try to get as many done as you can, and we'll do the rest tomorrow.